Why is trial and error central to reinforcement learning? Have you ever wondered how machines learn to make decisions? The answer lies in a fascinating process known as trial and error, especially in the field of reinforcement learning. This method is essential for teaching machines how to interact with their environment and improve over time. In reinforcement learning, an agent learns by trying different actions and observing the results. Unlike other machine learning techniques that use labeled data, reinforcement learning relies on feedback from the environment. This feedback comes in the form of rewards or penalties based on the actions taken. The agent experiments with various actions, learns from the outcomes, and adjusts its strategies accordingly. At the heart of this learning process is the relationship between the agent and its environment. The agent starts in a specific state, takes an action, and then the environment changes to a new state. After each action, the agent receives a reward signal that indicates how good or bad that action was. Through repeated cycles of trial and error, the agent develops a policy, which is a set of rules or strategies that help maximize rewards over time. This learning method is mathematically modeled by Markov Decision Processes. These processes assume that the next state depends only on the current state and the action taken. This simplification allows the agent to focus on learning the best actions to take in various situations. Trial and error is crucial because it encourages exploration. The agent must try new actions to discover which ones lead to positive outcomes. This is especially important in complex or changing environments. The agent must balance exploration, which involves trying new actions, with exploitation, which means choosing known actions that yield high rewards. This balance is a key aspect of reinforcement learning. In real-world applications, this trial and error approach powers various technologies. For instance, game-playing artificial intelligence learns strategies by playing numerous rounds. In robotics, machines learn to navigate or manipulate objects through practice. Autonomous systems, like self-driving cars, must learn to make safe decisions in different conditions. The trial and error mechanism allows these systems to adapt and improve without needing explicit programming for every scenario. From the perspective of artificial intelligence and machine learning, trial and error in reinforcement learning shows how systems can learn from experience, much like humans do. However, this approach also raises ethical questions. It is important to ensure that the exploration phase does not lead to harmful actions, especially in real-world situations. Tools like Chat Generative Pre-trained Transformer, DALL-E, and Midjourney, while not reinforcement learning agents themselves, reflected the broader artificial intelligence landscape, where learning from data and feedback is essential. Productivity plugins that incorporate artificial intelligence may also benefit from reinforcement learning principles to optimize user interactions through adaptive feedback. In summary, trial and error is central to reinforcement learning because it is the method through which agents learn effective behaviors by interacting with their environment, receiving feedback, and adapting over time. This process enables artificial intelligence systems to tackle complex tasks without needing explicit instructions for every possible situation.